Hey everybody, it's Justin from Built, and one of my previous videos I had dived into laser engravers, and I'm very happy I did. It's a really cool addition to my shop, but that was a very cheap, affordable beginner laser, and so it had some drawbacks. Particularly, it couldn't really cut very well. And in a wood shop, I would love to be able to cut thick wood with my engraver because there's so many uses for that in my workflow if it can cut well. So today, my friends over at Wizmaker sent me their brand new top-of-the-line diode laser that's just being introduced right now. And this laser is 36 watts. The previous one I tried was 5.5. So a huge difference in power. So I'm very interested to see how that converts over to how thick of material it can cut. And look at the different new options that it has. A very powerful diode laser like this can actually oxidize metals and turn them colors. So when it's engraving, it can actually make like pink and blue and different colors in the metal without any pigments whatsoever. Just the laser is causing this. So that's something that I'm very interested in taking a look at. So let's dive into it and see if Wizmaker can make the cut today on Built. Okay, so here's the new Wizmaker. It only took me 15 minutes to assemble this. Phenomenal. It was already pretty much assembled. All I had to do was just put screws in each corner and 4 screws on the gantry right there, and it was done. The big thing that you'll notice is the difference in laser size. This is the 5.5 laser. This is the 36 watt laser, so obviously it's much bigger. It also has this port right here that is for hooking up an air assist, and that's what you see this tube coming off. It did not come with an air assist, but it is already assembled ready for one. So I purchased a air assist on my own and hooked it up, so I'm going to be using that during this test. Wizmaker said that they're going to be coming out with one, but they don't have it out yet, so I just did my own. Another big thing is this has a really high fan area up above it, and this one is a lot more compact, which means that you can get it into a smaller enclosure space, which is nice. Now, this one cuts 400 by 400 millimeters. This one cuts 400 by 410 millimeters. So even though this one's bigger, this one actually has a slight larger area that it can cut with. If you saw in one of my last videos, I completely re-gutted this area, and the main focus was because I wanted to put in a laser engraver. Now, I'm not done with this part of the remodel yet, but I wanted to start filming this video, so I said, okay, there's going to be all sorts of stuff here and here, and more finishing work, and of course, you know, sealing all the wood and everything. But this is the enclosure that I made for the Wizmaker. And this has a direct vent system that sucks all the air of it and put it outside. That way I'm not smelling smoke inside of the shop, or if there's any sort of dangerous, hazardous chemical that's being released because of something that I'm engraving, it gets sent out. And there's height adjustability and all sorts of stuff. But the big one that I wanted to point out just for this video before we get started is the laser-proof acrylic. Do not go on Amazon and randomly buy something without reading it because it says laser-proof acrylic in the title. I almost did. But when you really start digging into the description of these things and the comments that people are leaving below, it's usually acrylic to be cut in the laser engraver, but it is mislabeled as laser proof. And so it does not protect your eyesight whatsoever. So make sure what you are buying will actually protect your eyesight. When this laser's going, I want to be able to look through here without specialty glasses on and see that everything's going on just fine without my eyeballs melting, right? So make sure if you're going to do an enclosure like this, and I highly recommend an enclosure because it keeps the smell down, make sure that you use the real stuff. I'll link this down and below. There's a million different places to get it. I'm just letting you know, like, be careful when you're purchasing it that you actually read and make sure that it really is laser proof. So I'm on the newer end of laser engravers, and a great learning opportunity, that's what we're going to call it, just occurred. I'm setting up the laser to, you know, start doing all my tests for this video. And typically what you're going to do with a new laser is all the different materials that you're going to use, you're going to put it in there and you're going to have it run a material chart. And so it'll show you based on the speed and power for each material what is the best setting to run it on. And then that's what I was going to go off of to start running all my tests. So because this is a very powerful laser, I actually started a fire in my laser engraver already. And I had to stop it right away because right here where it was going at 100, and I'll show you a couple clips as like it was full on fire char going. Had burning embers in there, and actually it went through pretty deep on here on a single pass. So I was actually, I'm impressed with the power because this is 3/4 inch hard maple. And while it didn't go all the way through, I'd probably say it went 75% the way through. So cool for cutting, but not for fire. I don't like fire in my shop. So when you are doing these, you have to pay special attention that now that I have a very powerful laser, I need to dial it back big time. So I don't even want to run the test going very, very slow with this because it's just going to catch the wood on fire and burn all the way through here. This wasn't for cutting. This was tests to see how I could do it with engraving. And oh man, we're really in there. So be careful with your powerful lasers, guys. So the way I'm going to progress through this video is I'm remaking some of my projects that I did in the last one to see if we can do them way faster, because this is a more powerful laser, so it should be able to do the same tasks faster. Then I'm going to do my cut tests and see how thick a material we can get through. And then finally, I'm going to work on oxidizing metals into colors because I see that in the marketing. But when I looked out there to try and see if there was any other videos out there, I found two in all of YouTube, 2 videos on oxidizing metals with your diode laser. And so I'm very interested to see if I can actually accomplish this feat. So starting off with products that I did in the last video. We're going to start with my cutting board analogy where I did this Miller family engraving into it. And you'll see that on the Atom Stack 5.5 laser, it took me 12 minutes. And here on the Wizmaker, it took me 3 minutes, 40 seconds. So the exact same engraving, same size, but it took me about 1/3 of the time. Now, you might notice on close-up that the one from the less powerful laser is darker. And that, in some ways, is a little bit better, but in reality, when you really look at it, it's char. So it really actively burned it. And I can do that on this one, but this is more of what you want. This is a real engraving without the char. So it removed material, so I can hit it with my fingernail here. It's slightly indented, but I didn't create char because that char will also wash away and rub away as it has contact and stuff. So this is really the better engraving if we want to think about it. So it did a better engraving in 1/3 of the time. So very cool there. Next, we move on to my big Bittner-built subscription sign, and again, you will see the color difference. The 5.5 watt laser one is very blackened, and if I get my finger in there, I can produce a little bit of char on my fingers, and this one is the Wizmaker. Now, this one took me 30 minutes to do, and this one took me 16 minutes to do, so about 50% half the time. Again, it gave me a better engraving, and I made sure what I was trying to do in the recreation was get the same depth, because in this thing, since it's a QR code, you want to have depth in on the squares, so they are the same depth, but this one didn't char it. So interesting stuff there. A huge surprise was when we go over to the metal business cards. So in the last video, I did this metal business card, and in all honesty, it is very light. You know, when I look at it close and I kind of, move it with the light a little bit, I can see everything, but it is not super, super obvious. Now, when I look at my time to do that one, it took me 1 hour, 45 minutes to engrave this business card. 1 hour, 45 minutes. To do this business card, also on the same aluminum, this one only took me 2 minutes and 29 seconds. So amazingly faster than this. I had also done it on this blue one, and I did a whole bunch of tests. That's why I have it cut up. I really like the blue on there. That's really cool. But why I cut this one was I found that I was going way too slow on the back side of this. I was going way too slow, and it actually caused like blackened char on the metal, and it warped the aluminum. This, I am pretty sure, is a piece of aluminum. And it caused it to bend and twist. And so that's why I cut that piece off to bring it back to flat again when I tested it on the other side. And then I did one on this one. It was completely fine. So you can just sail through engraving on aluminum here. Super awesome. But that whole warping process I'm going to get into in a little bit when we talk about the other metal stuff. Being able to move fast on this is awesome, and it prevents that warping. Finally, this is a cutout, but this was from the previous video where I cut out all these pieces for a layered sign. You know, you put the welcome on top of this, and it looks pretty good, especially once you paint it and whatnot. So this is a really easy sellable product that is made with literally like $2–3 worth of material. So very cool. Now on the Atom Stack 5.5 laser, this took me 1 hour and 40 minutes to cut out. It had to go very slow, and it actually had to do 2 passes in order to cut this out. Now on the Wizmaker 36 watt laser, I was able to cut out the house, everything right here, in 9 minutes and 50 seconds, and the welcome was 4 minutes. So let's call it 14 minutes in total for me to produce this, where the other one was 1 hour and 40 minutes. So huge, huge difference in cutting. When you have a machine that is more than capable to do the task in one turn very quickly, I mean, wow, this saves a lot of time in comparison. So the big comparisons that I saw is, you know, just doing your regular engraving in hardwoods and whatnot, it moved a little slow, but it was still 2 to 3 times faster. On the metal engraving, it was 1,000,000 times faster, and on the cutting of this thin material, also 1,000,000 times faster. So if those are areas that your use case for this is gravitating towards, then it really kind of says, hey, you need to get a more powerful laser because it's really going to speed up your processes. Next, we're on to cutting. So first off, I wanted to start with the 1/4 inch material, which the other machine could technically get through, though it took many passes. So for this machine, it was easily able to cut through this 1/4 inch piece of poplar in one cut, one pass, no problem. It was capable, however, it had to be on 90 or 100% for one pass cut of the MDF that's 1/4 inch. And again with the pine plywood that's 1/4 inch, I was able to cut through it very easily. When we moved over to 1/2 inch material, this was where, if I had to place a bet, this was where this machine was going to be able to cut, and that's it. So first I tried a 1/2 inch piece of pine, and it was easily able to cut through it in one pass at many different settings. So that was encouraging. It was capable, but I would not recommend it on MDF 1/2 inch. As you can see on this side, I attempted many cuts, but when you flip it over, I only got through a couple times, and that might have even been at multiple passes. And when I look at the material, and I'll show an up-close version of this, it really starts to burn and spread out almost into like a catching the material on fire. When you look at cross cuts of these things and you see this big black kind of blob appear, that means that the laser's hitting it and it's not going anywhere, and it's spreading out to the sides and it's burning width instead of cutting straight through. So the MDF, being a very dense product, it really didn't want to go all the way through. Now on the 1/2 inch plywood, I was able to cut through a couple times, and I do believe that it can do this, but this is one of the, at least for plywood, this is probably its maximum. And you're probably going to have to run a couple extra passes just to make sure that it cleanly goes through. but it can do it. So we're down to 3/4 inch material, and honestly I felt this was just a waste of time, but I wanted to see how thick I could get through. And so remember how we started a fire with this in the beginning of the video? Well, fire number 2. So in one day testing this machine, I had 2 fires. This was in pine plywood, and I was just trying to burn through there, so I'm at like 90% power and just going over the same spot again and again, and it's going to catch a fire. So it's not the machine's fault. It's totally my fault, and it's because I'm pushing the machine as hard as it can because I'm trying to see what I can accomplish with it. Now, in your use of these type of machines, you should be running it at the lowest power level you possibly can to accomplish the job. At a fast speed, too, because lots of power moving very slow is what, causes a fire with these machines. So make sure you're using your machine cutting what it's supposed to be cutting and using it at the fastest, most optimal settings. So pine plywood does not work. It got about 60% of the way through. I then tried it on hard maple, and again 60% of the way through. And I tried it on a birch plywood. Now this had an interesting result because on the back I almost made it through. That's very interesting. So what I did was I cut it open, and I wanted to get really close on this one. And you can see that it's all burnt out here. If I put my finger in here, it is total soot city. So while this could possibly cut all the way through, honestly, it's not going to be a clean cut. It's going to have a lot of burnout in all directions. So I would still say this is a no. Now, the dark horse of everything was this 3/4 inch solid pine, because we cut 4 out of 5. 4 out of 5 attempts on this, and the 5th did cut through, but it had a little tag that held it. So not only did it cut through, but it cut through clean. These materials are not leaving soot on my hands. There is no additional burnout inside here. It is cleanly cut. This is a capable cut on this machine. So, wow, that's actually really cool. I did not think that it was going to be able to cut through 3/4 inch materials. Now, when we think about it, a solid piece of pine has a lot less resistance than like this piece of pine plywood that has glue at every single one of these layers. So you're cutting through pine and glue. And the glue is probably what's inhibiting its progress. With hard maple, it's a very stringy type of wood, and it's very hard, so it's very condensely packed, and so that's what's inhibiting its cut through. So maybe cork, solid pine, maybe poplar. I haven't tried it. I didn't have a piece that thick, but maybe it might be able to get through poplar as well. And some of the other softer woods that aren't as dense. 3/4 inch is possible on this machine. So that was a very cool thing to be able to find. I was very, very surprised. And that's why I actually did 5, because I'm like, no. Try it. Keep doing it. So very interesting there. So now we're on to etching metal. The technical way would be to oxidize the metal to get colors on it. Now obviously we can engrave metal with this machine. I've already shown you how we can do that, and it's actually done very quick. But to oxidize metal is a whole different other thing, and it can only be done apparently with high-powered diode lasers or extremely high-powered CO2 and fibro lasers and stuff. So this is the level of laser that would be required to do this type of thing. Now, like I said before, I searched out YouTube channels because I first put a piece of sheet metal in here, and I attempted it, and I got nothing. I got like a little etching, no colors. And so I'm looking around to see what are people doing in order to make this. I tried asking the manufacturer. They pointed me in the direction of using stainless steel. So I ordered a couple pieces of stainless steel, and I also ordered a piece of titanium. Super expensive, but let's try it, right? So there are products that you can spray on metals before you hit it, and it's going to make a darker engraving on there. That's not what I'm trying to do. I'm trying to just hit a piece of metal with a laser at a certain frequency and power to get it to produce a color. And so once the stainless steel came in, this is brushed stainless steel on one side and mirrored stainless steel on the other. It could not produce anything on the mirrored stainless steel, and honestly, I feared that it was going to damage the machine because it could easily reflect it back up. But I was able to get some colors when I did my little power setting grid here. And if we look closely, I was able to get really the best one in there is probably the blue color that I got at 4467 at 60% power. So you kind of get some other hints of colors in here, but you know, overall I got this blue. So cool, I actually accomplished something. And so I figured, you know what, my range is very low. I produced char on this metal at some of the very high settings. So I said, let me go ahead and run this test again. I cut the metal in half so that I could run it again. And I narrowed my field down more. And now I got a whole bunch of colors on this one. So I was able to get blues, browns, reds, yellows in here. It's a little hard to discern them. You know, you might confuse it a little bit with like burning over color. But no matter what, we know the blue is a color. And I do like the other colors that are in here. Now, one thing I want to point out. If you take a look at this piece of metal, it is curved like this. And you have to run this slow and at a powerful setting in order to do this. And it heats up the metal and causes it to warp while you're doing it, which then screws up your results. So even though I got these results, some of these results aren't correct because the metal moved maybe up or down based on where it should be. So the laser's hitting it not precisely, if that makes sense. So that creates a little bit of difficulty for me in the recreation of the color. It also, I had these pinned down. I did it on a honeycomb bed to allow for ventilation. I have ventilation in there going. You know, the only other things I could have done is probably like squirt water in this thing, but I didn't know how that was going to react. So I was hoping that the hold downs that were really holding the metal down would have done something, but ooh, no, it wants to come up. Now, part of that is because this is thin. But stainless steel is expensive. I mean, I spent 20 bucks on 2 pieces of stainless steel this thin. If I wanted to order really thick stuff, it gets up there. So just for playing around for the video, I went as expensive as I was going to go for this video. But the thicker you do, the better. So now I had my color chart for stainless steel, so I decided let me go ahead and try to actually cut something. So I did a manly skull. I mean, the skull of a butterfly. Yeah, I tried to do a butterfly. So I wanted to do a whole bunch of different colors on this butterfly all over the place. And so you'll notice that I did achieve some colors over here, particularly a really good blue. You can see a little bit of a red and purple going on in here, some purple over here, some yellows. But I have nothing over here practically. And why is that? It's because the whole thing started bending and twisting as soon as I was doing the project. So, but what I do want to say is on stainless steel, proof of concept, right? So it can do it, but you really got to go with thicker material that is going to inhibit bending. And that's where we come to titanium. So the titanium piece that I got, it is 4 inches by 4 inches and cost me 14 bucks for this piece of titanium. So I only really had one shot to do a color gradient on this side and one shot to try and do a product on the other side. Now this is a little bit thicker. This is like 1/8, I would bet, of an inch. And when you look at the color chart, oh baby, like I got whites, purples, blues, browns, and some yellows in here. And that was just in the range that I did. If I had more pieces and I could have broadened out the range to give me a bigger spectrum, I'm pretty sure I could have even found some other cooler stuff. So that was awesome. So titanium is a win for this product. The colors are really nice and vibrant. As soon as I took it out, I showed my wife. She's like, wow, that that looks really cool. So if you're thinking about doing a oxidizing of metals, titanium is the one. And then I attempted my super manly butterfly as well on the other side, and this time it actually came out. And so this butterfly has light blue, dark blue, purple, brown. It didn't really produce red like I thought it was going to, but you know what? Overall, I'm going to say user error on some of these things. But because this material was thick, it did not warp. I'm also betting because it was titanium, it did not warp. This thing is hard, and it actually came out really, really cool. I actually wish I hadn't done a butterfly and done something cool for like my business or something on this, but you know, I thought a colorful butterfly was going to be the one. But I am really happy that I actually accomplished it. So again, I'm not super, super high-end laser guy, right? Like, there are people out there with tons of laser engraver video channels, a lot more experience than me. I was really impressed that I was able to do it, especially because I couldn't find any source material and nowhere could I find anybody telling me, you know, what schematics I need to do with this stuff. So that being said, at the end of this video, I'm going to put down all of my stuff. That way, if you get this laser engraver or even one that's of similar power, you could hopefully plot in those data points and be able to recreate this type of stuff easily. So hopefully I can help you guys with that. So the Wizmaker 36 watt diode laser, it's the WM-LE003. It's going to be available as soon as you see this video, so it's actually being unveiled as this video comes out. So thank you very much, Wizmaker. I'm flattered that I got to do a product introduction video for you. So what are my feelings, what are my thoughts about this machine? As always, I only give unfiltered, honest thoughts on all of this stuff. And so first off, build quality, awesome. It took me 15 minutes to assemble this. It's rigid. I didn't have to do any calibrations or anything. My kids could have assembled this in 15 minutes as well. So very simple and easy. It was packed in Kaizen foam. I love that. When you care about your product, your customer cares about your product too. Thank you very much for that. So it came perfect, no issues out of the box. When it comes to engraving, it is 2 to 3 times faster on hardwoods than my cheaper laser. So if you're into doing production engraving, great. You're definitely going to save some time. When I was doing the aluminum engraving for the business cards, it was a bajillion times faster. I mean, it cut production down to 2 minutes and 40 seconds. So that's awesome too. I'm going to make some business cards for myself out of aluminum for my consulting business because I think they just look awesome. And since I have a machine that can do that, sweet. When it comes to cutting, this surprised me. I did not think that there was going to be any 3/4 inch material that it was going to be able to cut through, let alone cut through cleanly, and it did it. So that is awesome. Now, if it could have cut through cleanly on the plywood, I would have just been like, yes, this is my new favorite machine in the world, and I'd be using it all the time. But I can't fault it for not being able to do that. I can more just focus on being excited that it can cut some 3/4 inch materials. That's great. Now it can cut 1/2 inch materials all day long. And so that's awesome for making pattern templates out of this thing. You know, when you're making a template, being able to make it out of a 1/2 inch material means that you're going to have a large piece of material for your bearing to run on. And I kind of see it as like my permanent templates. When there's something that I'm making a lot of, I would make it out of 1/2 inch material, and so this fits the bill for that. It's also going to be able to make an entire array of different products that you're just going to be able to easily cut out and sell. So that is awesome. Now, the metal work on here, oxidizing stainless steel and titanium, was very cool. I'm probably going to have to make a separate video of that because there's only 2 that I was able to find, and I tried hard to find other ones out there because I was looking for settings. I only had 2 pieces of metal, and so I wanted to get my settings right off the bat, and there was nothing for me to go off of. So think about if you have like a stainless steel tumbler mug. You could not only engrave it, but do it in a color. That's really cool. Put jewelry in here, like thicker pieces of metal jewelry, and be able to get colors out of it in addition to a permanent engraving. That's really cool. You can't do that with low-powered CO2 lasers. You need a powerful diode laser, which is, this is it, or you need really powerful like fiber lasers and really powerful CO2 lasers that are many thousands of dollars. So this is going to be the thing that's going to get you there at the lowest price point. So if, you know, colored metal is your thing, this is the one to buy. Now it is over $1,000. So is this a beginner machine? No. Unless you're the beginner that saves their pennies to buy the right type of machine the first time, every time. Most likely, I would say a lot of beginners, you should be starting off with a cheaper machine and graduate to this one. But it's awesome. It has a lot of other accessories too. I loved that it had the air assist port built into it. So all I had to do was hook up a hose line to it and I had air assist. That creates cleaner cuts. It puts this air buffer in there to not only clean out the cut, but it also reduces heat that's going on in there to reduce fire, which we had too. So make sure to use your machine properly. It also has a camera system that they sell that, you know, you can put down multiple units in here in Lightburn and it will just duplicate onto each one your production. So if you're somebody who's producing stuff, you can put multiple things in here and run multiple batches at the same time. So with that camera attachment feature, that's really cool too. I hope to play with that pretty soon as well. Overall, I would say it's a winner. I'm not sugarcoating it because it's, you know, they sent me this review unit. I really like this machine. It is at a higher price point for some people, but in comparison to the other machines at this price arena, it's pretty cheap as well. So I think Wizmaker did a really good job with this one. So I'm only 2 months old on YouTube, and I'm hoping to hit 10,000 subscribers this month. If you got some good, you know, intel from this video, please like and subscribe. It would mean the world to me. And of course, stay safe in the shop. I'll see you in the next video.